Hello guys, welcome everyone to another live stream. Today we are gonna continue our series of 75 questions 0 to hero in Leetcode. Today is our third day and it's probably the seventh question. So how are you all doing? So guys, we'll start today's live stream. So we'll go to our first question of the day. The question is, reverse k nodes in a group. So the question goes this way. Given the head of a linked list, reverse the nodes of the list k at a time and return the modified list. K is a positive integer and is less than or equal to the length of the linked list. If the number of nodes is not a multiple of k, then left out nodes in the end should remain as it is. You may not alter the values in the list nodes. Only nodes themselves may be changed. So, the question is this way. Example what they have given 1, 2, 3, 4, 5 and they have given k is equal to 2. So the first two values should change and the rest all should remain the same. And our output will be 2, 1, 4, 3, 5. So now what I should do after every k iteration. For example here this 2 change. First 1 and 2 will change into 2 and 1 and then 3 and 4 will change into 4 and 3. 5 will remain as it is. We'll go to one more example. Same numbers 1, 2, 3, 4, 5. They are given k is equal to 3. First it will change 1, 2, 3 will change to 3, 2, 1 and the rest will remain same. 4 and 5 is gonna remain same. So we are given with the constraints here. Number of nodes in the list is n and uh, k is smaller than n, smaller than or equal to n and greater than or equal to 1 and the value of n is in between 1 and 5000 where both 1 and 5000 are included and node.val is between 0 and 1000 including both 0 and 1000. Now we'll see the question, we'll understand it. Okay. Reverse K group. Simply I'll write it as reverse K group. So the question says head is given here. I'll write head as what? 2, 4, 6, 8, 10, and K value I'll keep as 2 first, and then I'll keep K is equal to 3. Our output here in the first case, our output in the first case. So after every 2 terms it should change. First where it's gonna change at 4. So it will become 4 comma 2, and then again it will change at 8, 8 comma 6, and 10 will remain as it is. So our output will be 4, 2, 8, 6, 10. And now comes another next, when K value is equal to 3, our output is gonna be, it's gonna change at, so this is our input array, input head 2, 4, 6, K is equal to 3, so it's gonna change at 6, it's gonna become 6, 4, and 2, and the rest 2 will remain as it is, 8 and 10, they're gonna remain as it is. So this is what is the question given. Now we are gonna see two approaches to solve this question. The first approach we are gonna use is iterative approach. We'll use stack for this. So our first approach, first method, what is gonna be our first method? Using stack. Use stack and iterative. Okay, give me a second. I'll just write iterative approach, it's better. So iterative approach. So what is gonna be our intuition here first? What is gonna be our intuition here, guys? So the first point, we are gonna use a stack to reverse the linked list. Reverse the linked list. In groups. Now we'll go to our second point, which is very important. We can reverse the order using a stack by pushing nodes onto stack and then popping them. We can link them together in the reversed order. So next point, stack allows reversing order of nodes of effectively, efficiently, by pushing into stack and popping them. After this we can by linking them, then we can link them. After popping them, we can simply link them, linking them together in reversed order. So after this, after intuition, we are gonna go for approach. I've already said iterative approach using stack. So what we are gonna do here, first we'll initialize pointers. In our first step, we are gonna initialize pointers. Initialize pointers. Which one? The first is curr, current node. This is the current node to traverse the list. And the next one is prev, tail of the previously reversed group, tail of previously reversed group. And next is tail, tail of current group. Tail is the tail of current group. Before reversal. Okay, this is our first point. We'll initialize pointers. Now we'll go to the next step. Our second step, we are gonna form groups and push into stack. So I'll keep this as group formation and stack push. So now the first step is we'll push the nodes into the stack while traversing the list. Here, first step, push nodes into stack while traversing list. After that, what we'll do is, if there are fewer than the nodes, for example, when we took k is equal to 3, the last two were left. In that case, they will remain unchanged. If there are fewer than nodes unchanged. Okay, there's our second step. We'll go to our next step. Here, reversal using stack. So here guys, anyone what will be doing here? Anyone in the so guys, now if exactly nodes are pushed, if will pop them from the stack. And link together in reversed order. So, after this, we'll connect the reverse group to previous group, connect reversed group to previous group using the prev pointer which we declared. So we are gonna use prev pointer and we are gonna link, we are gonna connect the reverse group. Now our final step to handle edge cases. Here what we'll do is, for last group where the case here will be last group has fewer nodes. So now what we'll do is, we'll directly connect them leftovers, leftover nodes basically, by without reversing them, without reversing, without reversal. Yeah. So this is our first approach. I'm gonna go to the code now. Here is our code. I'm gonna add commands for this for better understanding of the code. This is our stack. I'm sorry. This is our stack, and after the stack we have the 3 pointers. We know why the pointers are used. CURR is used to traverse the list. Prev is used to link the reverse groups, and tail is the tail of the current group. And then here we push k nodes into stack, and here we'll mark the tail. We'll mark the tail of the group basically. That's what, mark the tail, and then reverse the group. If it has k nodes. So here we'll update head value. Head is equal to prev, and here is for the edge case, which is basically leftovers. No reversal. So now I'm gonna run this code. It works well for the given test case. I'm gonna submit it. As you can see, it's not the most optimized code, but it is still accepted by the it's still accepted and it passes all the given test cases. So now we'll go to our next question. We'll go to our next question, guys. Sorry, we'll go to our next approach basically. So we just did using one approach, now we'll go to the other approach. Anyone in the chat, which is the next approach we can use to solve this question? Okay. Now we'll go to our second approach, second type, second method. So our second method is recursive method. So now what I'm gonna do is first our intuition. Okay. Intuition. First point of intuition. We'll use recursion. We'll use recursion to reverse linked list. Recursion to reverse it. So next point, it will follow divide and conquer strategy. We'll use divide and conquer method. What we'll do is reversing one group, at a time, and then calling the function again, calling the function recursively, calling the function recursively for remaining part, for remaining. So this is our this is our intuition for this question, the same question, the second method. Now I'm gonna go to the approach. Approach is already I have explained now what we are gonna do here. So now here what we are gonna do is first we'll count the nodes. Count nodes. For this what I'll do is we'll traverse nodes using CUR pointer, and then if fewer than the nodes are left, if fewer left, if fewer than nodes are left, I'll return the current head without reversal, without any change, without changes, without modification, whatever you wanna say. So, and the next point we are gonna use here is in our second step, we'll reverse the current group. Reverse the current, we are going to reverse the current group. For this, what I'm going to do is, I'll use a helper function, reverse. Helper function, reverse with start comma end to reverse the current group. Reverse current group. Start is the beginning of the group. The beginning of the group. Beginning of the group. And end, node after the group. Node after the group. So now in our third method, in our third step, what we are going to do is, we will reverse current group. Sorry guys, that's done. We will call the function recursively. Recursive call. So for this, we'll make a recursive call on remaining list, on the remaining list, and attach it to reverse group's tail. Reversed group's tail. And then its recursion, this process is continued. This is continued until end. Until end. So now I'll go to the code. Here is our code. I'll add commands for better understanding. Here we'll count the k nodes. And after that, if fewer than k nodes, return current. Will return the current head. Will return the current head. And then this is our recursive reversal. Recursively reverse remaining list. And then finally, this is our helper function with start and end. These are helper function. Now I'm gonna run this code. It's accepted for the given cases. I'm gonna submit it and check. And you can see that this is accepted, as well as this is the most optimized version where it takes 0 milliseconds and beat 100% of the people. Whereas our previous code, whereas our previous code worked only when, sorry, whereas our previous code took 2 milliseconds and it bet around 6% or 8% of people only. So now we'll go to the uh, what do you think is the time complexity and space complexity of both the cases? For both the methods, what is the time complexity and space complexity? So I'll go back to method 1 just for writing time complexity if space is there. I hope. Oh no, man. Okay, I'll write it again. I'll write time complexity method 1. So in the method 1, the time taken is equal to the group of k nodes are pushed. So it's gonna take O of k, and then there are n by k such groups. There are n by k such groups, which is gonna lead us to O of k into n by k, which will give us O of n. And for method 2, and for our method 2, it's directly exactly the same. Reversal is gonna take O of k time, reversal, and then there are n by n by k groups. So O into k, O of k into n by k and k cancels, which is gonna give us O of n. And now we'll go to our space complexity. Space complexity method 1. Method 1. There are k nodes. At most we have to store k nodes, and therefore it's gonna take O of k. For the first method it's O of k, and for the second method, each group will cause one recursive call, and there are n by k, one recursive call per group, and there are total n by k groups, which leads to the space complexity of O of n by k, which is way more lower than O of k. So now we'll compare both our codes, like the first method and the second method. I'm gonna divide it into halves. So iterative, recursive. Now I'll keep one more column here. We know what approach we used. Iterating using stack, iterate using stack, and now in this thing we use recurse using helper function, helper function. Now time complexity O of n time complexity and space complexity. I'll write both. And space complexity is O of k. Time complexity, and this is space complexity. And here it is O of n, time complexity, and the space complexity is O of n by k. This is space complexity. Now, memory efficiency, it's clear that stack uses extra space. And readability is always better with stacks. Sorry, readability is always uh, better in recursion because it's cleaner and simpler. Edge cases. Now edge cases, I'll write it as edge. Edge cases are here handled manually handling leftover nodes basically. I'll write it as leftovers. Here naturally the leftover nodes are naturally handled. And next point, performance. We clearly saw which is better. Iterative is slightly slower because of stack operations. This is faster as it's recursion or recursive based reversal. Until it's exclusively mentioned that we have to use iterative approach, it's better to use recursive approach, and we can or else we can use the iterative approach and then we can also show the recursive approach optimizing it. So there's a very important FANG question asked in a lot of FANG interviews. It's asked by a lot of times, it's asked by companies like Meta, Amazon, Apple, Google, etc. The MANG companies. So guys, anyone in the chat, is there any doubts for anyone? Any doubts, guys? Any doubts, chat? Anyone? Okay guys, since there are no doubts, I'm gonna end today's live stream with this. If anyone has any doubts, you can ask in the comment section. I'll reply them. So with this, we are gonna end today's live stream. Thank, thank you guys, everyone for who joined. We'll stream again maybe tomorrow or day after tomorrow, as soon as possible, with another one FANG question. all the questions in this series are very important fan questions or other questions which are as per the top companies. So I'm hand picking all those questions. So with this, we are gonna end today's live stream. Thanks everyone for joining the stream. Until next time, have a good day, have a good night, have a good day. Enjoy. Good night, guys. Bye.